So starting with byte. So byte is an integer data type that occupies 1 byte of space or 8 bits with values ranging from negative of 128 to plus 127. So let's create a variable of type byte. We'll say byte days in week equal to 7. Now coming to short. Short is also a signed integer data type which occupies 2 bytes of space or 16 bits with values ranging from negative of 32,768 to plus 32,767. So let's create a variable of type short. We'll say hours in month. That turns out to be 720. Now coming to int. So int is the most popular of the pack. Also stores integer numbers ranging from negative of approximately 2 billion to plus 2 billion. And it occupies 4 bytes of space. So let's create a variable of type int. We'll say int minutes in year, and that turns out to be approximately 525,600. Now, nothing stops us from assigning smaller values which are suitable for byte or short to be assigned to an int. So we could have said instead of byte days in week, we could have said int days in week equal to 7. So it's absolutely fine. But then what should be the motivation behind using byte and short? Firstly, we must use smaller data types wherever possible for establishing parameters or limits on the assigned values. What if we are building a scientific application where you need to enter the elements of periodic table with their atomic numbers? Now we know that the atomic number of the heaviest element is 118. So the maximum value of an atomic number will not surpass 120 or 125, even if the newer or heavier elements are discovered. And so to avoid possibility of human error, we must define the data type of atomic number as byte rather than int. So that if by mistake user adds say an additional 0 in the end of an atomic number, then it should result in a compilation error rather than such an erroneous value getting stored. Secondly, and most importantly, byte and short must be preferred over int when defining large arrays, if the values fall in the limits of short or byte. We will talk about arrays in chapters to come. But in simple words, arrays are collection of variables that are sequentially arranged in memory, just like sequence of rail coaches. So here what we are saying is that if we are storing smaller values within range of byte and short in a large int array, then we are wasting memory. For example, if we have to store the ages of all the people in the city, of course, the age would never be in order of thousands. It will always be in order of byte. So using int to store ages of hundreds or thousands of people in a city would be waste of memory. And at the same time, if we think the use of byte and short in a mathematical calculation would have some performance benefit over int just because byte and short are smaller data types, then that's absolutely incorrect. In fact, when performing mathematical calculations, byte and short are marginally less efficient than int, and that's because all byte and short values are converted to int before performing any calculations. We'll see that in action in a little while. And now coming to long. So long is the biggest signed integer data type, occupying 8 bytes of space or 64 bits with values ranging from negative of 2 raised to the power 63 to positive of 2 raised to the power 63 minus 1. So let's create a variable of type long. So we'll say long, let's say seconds in year, and that computes to 315,360,000. And let's create an even bigger one. Let's say long seconds in century, and which comes out to be 100 times of seconds in a year. Copy this and let's add 2 zeros. So that's it. Now let's output the results. So let's save it. We'll save it as test integer data types.java. And let's compile and run it. Now here we can see the compiler complains integer number too large. But didn't we say long is bigger than the collective wealth in the world? In fact, the max value that a long can store is more than 9 quintillion. And this value that we are trying to store is just somewhere around 3.1 billion. Then how is 3.1 billion too large for a variable of type long? Now we have to understand that this declaration step has two parts. One, memory allocation for the variable seconds in century, and second, initializing it with the value 31536 5 times 0. For a moment, let's just focus on the initializing part. Although the internal mechanism of JVM for initialization is not very clear, not known to public in general, but seemingly the JVM stores the value 31536 5 times 0 in a temporary memory before assigning this value to the variable seconds in century. Now, until and unless specified, the JVM just allocates temporary storage equal to 4 bytes, that is an int. But a 4 byte of space can take maximum value of approximately 2.1 billion. That is why this value 31536000000, which is more than approximately 3.1 billion, is a number too large. And so the compiler flags an error. Now, how do we specify or tell the compiler to use 8 bytes or a memory equivalent to a long instead of 4 bytes? And we do that by suffixing the value with a letter L. So we can either use capital L or a small l here. All right. So I prefer using capital L. So we'll go ahead with it. Let's save it and let's rerun. And you can see that it compiles fine. Let's run this program. We'll say Java test integer data types. And here we can see the result.